That's called ls tree. Now, why is this called a tree? Well, a tree is a data structure for representing hierarchical information. So in a tree, we can have nodes, and these nodes can have children. Now, a directory on the file system can be represented using a tree. Because each directory can have children, these children can be files and other subdirectories. If you want to learn more about this concept, you should take my data structures course. So ls tree means list all the files in a tree. Now here we specify the commit we are interested in, head ~1. And now look, these are all the files and directories stored in this commit. So we have gitignore. Right before that, we have a unique identifier that is generated based on the content of this file. So in Git's database, we have an object with this ID. Below that, we have bin. Again, it has a unique identifier that is generated based on the content of this directory. Now look at the type of this object. It's a tree. So files are represented using blobs and directories are represented using trees. All of these are objects that are stored in Git's database. Using the show command, we can easily view an object in Git's database. For example, if we type git show and then specify this unique identifier, or we can type only the few characters, as long as there is no ambiguity. So here's the content of our gitignore file. As another example, let's look at this object, this tree, the bin directory. So git show 64629. Here we have a tree. In this tree, we have this file, app.bin. So using the show command, we can view an object in Git's database. These objects can be commits, blobs, which represent files, and trees, which represent directories, as well as tags. We'll talk about tags in the future. So I told you that you should always review the stuff that you have in the staging area before making a commit. So let's say we review these changes, and we realize that the changes in file 1 shouldn't go in the next commit. Perhaps because these changes are logically part of a different task. So we don't want to have a commit that represents changes for different tasks, right? So in this case, we want to undo the add operation because earlier we used the add command to add file 1 to the staging area. Now we want to undo this operation. How do we do this? Well, in the past, we used the reset command, but a lot of people found this command confusing, especially with options such as hard or soft. That's why we have a new command called restore. Now make sure you're using the latest version of Git. Otherwise, what I'm going to show you is not going to work on your machine. So here I'm using Git version 2.28. And with this, we can easily restore files in different environments, in working directory or in staging area. So git restore, we want to restore file 1 in the staging area. So we type -- staged, and then we specify the file name. We can list multiple files here. We can also use patterns. Or if you want to restore everything in the staging area, we simply use a period. So here I'm going to restore file1.js. Now, when we run git status again, you're not going to see a green M here because all the changes that we had in the staging area are now in the working directory. Take a look. So git status -s. Look, we no longer have any changes for file 1 in the staging area. All the changes are in the working directory. Now, it's essential for you to understand how the restore command works. The restore command essentially takes the copy from the next environment. So in case of the staging environment, what is the next environment? The last commit, what we have in the repository. So when we restored file 1 in the staging area, Git took the last copy of this file from the last snapshot and put it in the staging area. That is what happened. Now look at file 2. File 2 is a new file because here we have a green A, which is short for added. So we have this file, we have this new file in the staging area, but this file doesn't exist in the last commit. So what do you think will happen when I restore this file? Well, because we don't have a copy of this file in our repository or in our last commit, Git is going to remove this file from the staging area and take it back to its previous state, which is a new untracked file. Let me show you. So git restore -- staged file2.js. Now let's run git status again. So file 2 is a new untracked file because we have 2 question marks. There are times that we have some code in our working directory that we want to throw away. Let's say we made some changes, but we didn't like those changes, so we want to scratch everything and start over. We can discard the local changes using the restore command. So here we have some local changes in file1.js. To undo these changes, we type git restore file1.js. When we execute this command, Git is going to take the version of this file in the next environment, which is our staging environment. It's going to take that version and copy into our working directory. We can also use a period here, and this will undo all the local changes. Now, let me show you something. So the command is executed. Now let's run another short status. But file2 is still here. Why is that? Well, this is a new untracked file. So Git hasn't been tracking this. So when we tell Git to restore this file, Git doesn't know where to get a previous version of this file. It doesn't exist in our staging environment or in our repository. So to remove all these new untracked files, we have to type git clean. Now take a look. By default, we get this fatal error saying require force defaults to true, and neither of these switches were given. So basically, Git is telling us that, hey, this is a dangerous operation. If you accidentally remove these untracked files, there is no way you can recover them. So let's run git clean -h for a quick help. Here we have this option, -f, which forces Git to remove these untracked files. We also have -d for removing whole directories. So quite often we type git clean -fd. Now, let's run short status again. File2 is gone. So this is how we undo local changes. So now you know that once Git tracks a file, it stores every version of that file in its database. And that means if you screw things, we can always restore a file or a directory to a previous version. So in this demo, I'm going to delete a file and then show you how to restore it. It's very easy. So we're going to delete file1.js. Now I told you that if we use the rm command in Linux or Unix-based systems, this will only remove the file from the working directory. So then we'll have to stage the change or the deletion. A better way is to use the git rm command. This will remove the file from both the working directory as well as the staging area. Okay, now let's get a short status. So in the staging area, we have a deleted file. Now let's make a commit, delete file1.js. All right, now let's say, shoot, we shouldn't have deleted this file. So what can we do here? Well, we have a few options. We can undo or revert the last commit. We're going to talk about that later in the course. But in this lesson, I want to talk about restoring a file to a previous version, not undoing a commit. So let's look at our history. All right, so here's our history. We want to restore file1 to the commit before the last commit. That is this commit over here. So we type git restore. Now let's have a quick look at the documentation. The restore command takes 3 types of arguments. We can supply a bunch of options. We can supply a source. We haven't done this so far. So by default, Git will restore that file from the Nix environment or the Nix area. So if the file we want to restore is in the working directory, Git will restore it from the staging area. And if the file is in the staging area, Git will restore it from the last snapshot or the last commit. Now, in this case, we want to change the default behavior. We want to restore a file from the commit before the last one. So we type git restore --source. We set it to head ~1. And then we specify the full path to the file. In this case, file1.js. Now, let's get a short status. So we have a new untracked file. So this is how we can restore a file to a previous version. All right, now let's look at the Git tools built into VS Code. So here on the left side, we have the source control panel where we can see all the changes in our project. So what we see here is similar to the output of the status command. We can see all the changed files and the kind of changes introduced in those files. So here we have changes in file1.js. We can click on a file to get a diff of that file. Now here we are dealing with a new untracked file, as you can see up here. That's why we don't have any code on the left side. Now we can stage this file by clicking on the plus icon. If we made a mistake, we can always unstage a file. That's very easy. All we have to do is to click on the minus icon. Now we have local changes in our working directory. So let's go ahead and stage this file one more time. Let's say we have reviewed our changes and we want to proceed to make a commit. Up here, we can type a commit message. So for this demo, we can say add file1.js. Just remember, this is not a good commit message because our commit should be based on logical units of work, not individual files added or removed, okay? So let's go ahead and make a commit. Good. Now, back to the Explorer panel. We have a fairly new feature here. I think they introduced it a couple months ago. If we click on a file and then open the timeline folder, we can see all the commits applied to this file. So here's our latest commit, add file 1. We can click on that commit to see the changes introduced in that commit. Here's the previous commit, delete file1.js. We also had another commit earlier, refactor code. Pretty helpful. Now here by default, we don't have a way to look at our history. We need to install a plugin to do that. I'm going to talk about that in the next section. Now let's look at the Git tools built into GitKraken. So here on the homepage of GitKraken, we go to open a repository. Here we can open an existing repository. We can also clone a repository. I'm going to talk about that in the future, but this is basically useful when we have a repository somewhere else, let's say on GitHub, and you want to take a copy of that repository and put it on our machine. Again, we're going to talk about this in the future. We can also initialize a new repository. For this demo, I'm going to open our Moon repository. So open repository, we go to our folder and then open. Good. So over here, we can see all the commits we have created so far. We can see the author of each commit, the commit message, and the date and time when the commit was created. Now we can click on each commit to see more details. So for this commit, we can see the commit ID. Here's the commit message, the author, date and time, and the summary of changes. So in this commit, we added one new file, which is file1.js. Now here we have multiple views. We have the list view and tree view. If you have changed multiple files in different folders, tree view is very helpful. We can also select view all files to see all the files in our project at this point in time. If we uncheck this, we only see the changed files. And by change, I'm talking about additions, modifications, and deletions. Now we can click on each file to get a diff of that file. So once again, we're dealing with a new file here. That's why we don't have any code on the left side. Now here we have two tabs, diff view and file view. If we switch to file view, we can see the snapshot of this file in this commit at this point in time. Now let's go back to diff view. We also have different ways of comparing the changes. So currently we're looking at the split view, which gives us the before and after code. We also have inline view, which is exactly like what we get in the terminal. We also have hunk view. If you're dealing with a large file with a bunch of changes in different parts of this file, hunk view is an easy way to see the changes in each section. Now let's make a new commit. So we have to go back to VS Code or our favorite editor to make the changes. Because GitKraken is just a GUI tool, it's not a code editor. So I'm going to go back to VS Code, open file1.js and write a new line of code here. Save the changes. Now, back in GitKraken, let's close this window. Over here, you can see we have one change in our working directory. We can click on this button to view the changes. So file1.js is changed and currently it's unstaged. We can click on this file to see a summary of the changes. So this is the new line that we have introduced. Beautiful. Now, we can go over here and stage this file or stage all changes. Now this file is in the staging area. If we made a mistake, we can always unstage this file. Super easy. So let's stage the file and then type a commit message. Let's say refactor code. And now let's make a new commit. As simple as that. So this is how we can use GitKraken to create snapshots of our project. But there is a lot more to GitKraken, and we're going to cover that in the future sections. In this section, we'll look at various ways to browse the history of our project. You will learn how to search for commits by author, date, message, content, and so on. We'll also talk about viewing a commit to see what files have been changed and how. Next, I will show you how to restore your project to an earlier point in time to the snapshot stored in one of your commits. We'll also see how we can compare commits to see what files have been changed and how. You will also learn to view the history of a file to see how it's evolved from day one and who has written each line of code. And finally, I will show you a great tool for quickly finding a bad commit that introduced a bug in your application. So there's a lot we're going to cover. Let's jump in and get started. In this section, we're going to work with a project or a repository called Venus, which you can download right below this video. It's basically a Git course represented as a bunch of plain text files. So here we have audience, objectives, sales page, sections, and table of content.txt. This project or this repository has some history that we can work with throughout this section. So download the zip file below this video, extract the content somewhere on your machine. When you're ready, watch the next lesson. All right, the first thing we're going to look at is the log command that you learned about in the previous section. In this lesson, we're going to study this command in a bit more detail. So here in the Venus directory, let's run git log. So here we can see all the commits in this repository. For each commit, we can see its unique identifier or hash. We can see its author, the author name and email, the date and time it was created, and the one-liner message or subject. Now, by default, all these commits are listed from the newest to the oldest. So here's our last commit. Now, because we have multiple pages here, we can press space to go to the next page. We can also use the up and down arrows to go up and down, like this. Now, to quit, we press Q. Okay. Now, let's look at some of the interesting options of this command. So git log, one of them that you already know is one line, which gives us a summary of all these commits. We can add additional options here. For example, if you want to see all the files that have been changed in each commit, we can use the stat option. Take a look. So in our last commit, 5 files have been changed. Here you can see the name of these files. We have audience.txt, objectives, and so on. In front of each file, you can see the number of changes. So for audience.txt, we have 4 changes. We have 3 insertions and 1 deletion. So 3 lines were inserted and 1 line was deleted. In total, 5 files have been changed, 7 lines have been inserted, and 4 lines have been deleted. Now, we don't necessarily have to use this option with the one-line option. For example, we can run git log stat. Now we have the full details about each commit, okay? Now, what if you want to see the actual changes in each commit? We can use the patch option. So git log, I'm going to use one line and then patch. So in our last commit, here we can see a diff of audience.txt. So these 2 lines were inserted. This line was removed, and then this line was added. Right after that, we have a diff of another file. So for each file, we can see exactly what lines have been changed. In the next lesson, I'm going to show you how to filter the history. In this repository, we have just over 10 commits. But in a real repository, we often have hundreds or sometimes thousands of commits, depending on the age of the repository. Now, we don't want to look at all of these commits. So let me show you a few different ways to filter the history. We can filter by author, by date, by commit message, by content, and so on. So let's run git log one line. Now, if you want to see the last 3 commits, we simply type -3 here. There you go. Now we can also filter by author. So one line. Here we type --author equals, and here in double quotes, we type the author's name. Let's say Mosh. So here are all the commits that I have submitted to this repository. We can also filter by date. So instead of author, we can use before and or after. So we can say, hey, show me all the commits from 2020, August 17. This will return all the commits created on this date and after. Take a look. We can also specify relative dates. That is pretty useful. For example, we can say, hey, show me all the commits from yesterday. Or we can say, show me all the commits from 1 week ago, or 2 days ago, or 1 month ago. Pretty useful. We can also filter by commit message or subject. For example, we can say, hey, show me all the commits that have the word GUI in their message. Here we type --grep equals, and here in double quotes, we type the search term, GUI. Just remember that this operation is case sensitive. So if we type GUI in lowercase, we're going to have a different result. Take a look. Here we have only a single commit that has the word GUI in its subject. We can also filter the history by content. Let's say we want to find all the commits that have added or removed a function declaration. So we type, instead of --grep, we're going to type -S, And here we're not going to use an equal sign. Instead, we're going to add double quotes. And in between the quotes, we're going to type our function name. Let's say all the commits that have added or removed this line. Now, in this repository, we don't have any code. We just have plain English. So let's find all the commits that have added the word objectives in capital. There you go. Here's the commit. Now, if you want to see the actual changes in this commit, we can use the patch option. You learned about it in the last video. So we bring up the last command, and then at the end, we type --patch. So in this commit, this file was modified, objectives.txt. And over here, you can see that objectives was inserted. Very useful. We can also filter the history by a range of commits. So let me bring up all the commits. Let's say we're only interested in the commits in a particular range here. Let's say from this commit to this commit over here. So we can say git log one line. Here we add the first commit hash. So FB0D184. Then we add double periods, and then we type the target commit ID, like EDB3594. Now, what if you want to find all the commits that touch a particular file or a bunch of files? Well, that is super easy. We simply type git log. We can optionally use one line. It's not compulsory. Now, if you want to find all the commits that have modified our table of content file, we simply add the file name at the end. So these 3 commits have modified this file. Now, sometimes depending on the name of your files, Git might complain and say, hey, this name is ambiguous. In those cases, we have to separate the file name from the options over here. So we bring up the last command, and here we use double hyphens to separate the file name from the options we're using here. You don't have to use this all the time. You have to use this only if Git complains about the file name, saying, hey, this is ambiguous, and I cannot figure out what options you're using. So in this case, we get the same result. Now, if you want to see the actual changes in each of these commits, once again, we can use the patch option. However, the patch option should be listed before the file name. So we cannot add it over here. It's not going to work because now, after we added double hyphens, Git is interpreting this as a file name. And there's no such a file called --patch. So to make this work, we have to use the patch option over here. Now for each commit, we can see the actual changes in our table of content file. So here's the default output of the log command. Now, if this is not what you want and you don't like the one-line option either, you can easily customize the output of the log command. Let me show you how. So we type git log --pretty equals format : double quotes. I know this is a little bit long, but the good thing is you don't have to memorize any of these things. You can always go back to the documentation or look at the cheat sheet that I've provided for you. So here in double quotes, we can specify a format string. This format string can be a combination of plain text and some placeholders that will get replaced by Git to display pieces of information about each commit. For example, if I type hello here, for each commit, we see the word hello. Of course, this is useless. So here we want to display information dynamically. Let's bring up this command one more time. And after the word hello, type %an, which is short for author name. Now take a look. For each commit, we can see the author name right after the word hello. Let's make this more interesting. So I'm going to remove hello and say %an committed. Now here we want to display the commit ID or hash. So we use %H. Now we can see the author name. Right after that, we see committed. And here's the full hash for each commit. This is too verbose, so we can use the lowercase h to see the abbreviation, like this. That is better. Now, if you look at the documentation for the log command, somewhere in the middle of the page, you can see the complete list of these placeholders. So we have capital H for displaying the commit hash, or lowercase h for displaying the abbreviated commit hash. We have quite a few other placeholders. So back to the terminal, let's take this to the next level. So right after the hash, we can say on, and here we can display the date, %cd, that is commit date. There you go. So you can customize the output of the log command any way that suits your needs. Now we can also colorize this output For example, we can display the author name in green. Let me show you how to do this. So we bring up the last command. Just before the author name, we type %, capital C, and then lowercase green. Look, here we have two placeholders. The first placeholder is for changing the color, and the second placeholder is for displaying the author name. Now, everything comes out in green because we didn't change the color after displaying the author name. So let's bring up the last command. Right after the author name, we can type %, capital C, and then lowercase reset. That's much better. Similarly, we can use a different color for the commit ID and the date or other pieces of information we have here. Once again, back to the documentation for the log command. Here you can see various placeholders for changing the color. So we have C red, C green, C blue, C reset, and C in parentheses, we can supply a custom color. Now, in reality, you're not going to remember all these details every time you want to look at the history. So in the next lesson, I'm going to show you how to create an alias for this long command. In Git, we can easily set up aliases for the commands that we use frequently, so we don't have to type them in their long form. Let me show you. So we type git config -- global. So this configuration gets applied to all of our repositories. Here in the alias section, we're going to define a new property. So we type a period, and then we type a custom command name. For example, lg, as in short for log. Now, whenever we type git lg, we want Git to execute a particular Git command. So we type that command here, log -- pretty. Now, because we have a space here, we should wrap this value with double quotes. Okay, so pretty equals format : Now here we have to use double quotes again to specify a format string, but because we have already surrounded the value with double quotes, I'm going to replace the inner quotes with single quotes. Okay, so here we can say %an as an author name, committed %h. So here's the end result. Now let's open up our global configuration file in our default editor. So we type git config -- global -e. So here's our git config file. Now down here in the alias section, we have the lg command that is bound to log with this pretty format. So now if we close this and type git lg, we see the output of our custom log command. So aliases are very useful, but in this course, I'm not going to use them because if someone watches the course from the middle, I don't want them to wonder, what is this custom git command that is not documented anywhere, okay? Now, before we finish this lesson, let me give you another useful example of an alias. So let's define another alias called onstage. With this, we can easily unstage the changes. So we're going to bind this to the restore command in Git. Once again, use double quotes. Here we type restore -- staged period. With this, we're going to restore all the files in the staging area. Now we can easily type git onstage. As simple as that. Now let's see how we can view a commit. We talked about this briefly in the previous section, but let's explore it in a bit more detail now. So let's say we want to view this commit over here. There are two ways to reference this commit. We can use the commit ID, or we can use a relative reference using the head pointer. So as you can see, head is in front of the last commit, and this commit we're interested in is 2 commits before the last commit. So we can type git show head ~2. That means go to the head, which is the last commit, and then go 2 steps back. So here we can see all the details about this commit. We can see the commit ID or commit hash, the author of the commit, the date and time, the subject, and a diff of every file that is changed in this commit. In this case, only a single file has been changed, and that is this file over here, stagingchanges.txt. In this file, we have 2 new lines, as you can see over here. Now, what if we don't want to see the changes? We want to see the final version of a file in this commit. Well, we bring up the last command, then we add a colon, and here we type the path to our file. So this file we're interested in is in a directory called sections. Here we have another directory called creating-snapshots, and our file is called staging-changes.txt. So here's the final version of this file stored in this commit. Now, what if we don't want to see the actual changes or the actual lines of code in this commit? We just want to see the files that have been modified in this commit. Well, we type git show head -2, and then we use an option called name-only. So over here, we can see all the files that have been added, modified, or deleted in this commit. With this option, we can only see the name of the files, so we cannot tell which files have been added, modified, or deleted. To get that information, we have to use a different option called name-status. So now we have the letter M here, which means this file has been modified. Now, what if we want to see the changes across two commits? For example, let's say we want to know what has been changed over the last 3 commits. To do that, we're going to use the diff command. In the previous section, you learned how to use the diff command to view the staged and unstaged changes. Now we're going to use the same command to see the differences between 2 commits. So we can start from head -2 and go to head. Now we can see a diff of every file that has been changed across these 2 commits. So here we have a diff of audience.txt. Below that, we can see the changes in objectives.txt and so on. Now, if you want to see the changes to a particular file, you can add the file name at the end. So here we can type audience.txt. Now we only see the changes in this file. Also, similar to the log command, here we have options like name status and name only to view the list of files that have been changed. So we can say name only to see the list of files that have been changed, or we can say name status to see the list of files and the type of change. In this case, we only have modifications, but if you had new or deleted files, they would be listed here as well. So we talked about viewing individual files in a commit. Now, sometimes we will want to see the complete snapshot of our project at a point in time. In these situations, we can check out a given commit, and this will restore our working directory to the snapshot stored in that commit. So our working directory will look exactly like an earlier point in time. Let me show you how to do this. So here in our log, let's say we want to restore our working directory to this commit over here. So I'm going to copy this. Now we run git checkout and paste the commit ID. We get this warning saying you are in detached head state. What is this? Well, this is one of those Git concepts that frightens a lot of people, but it's actually very simple. Let me explain it to you. So let's say here are the commits we have created so far. The first commit is on the left and the last commit is on the right. So as you can see, each commit is pointing to the previous commit. This is how Git can maintain history. Now, all these commits we have created so far are part of what we call the master branch or the main line of work. We'll talk about branches in detail in the next section, but for now, what you need to know is that in Git and many other version control systems, we can have multiple branches to work on different stories in isolation. Every Git repository has a default branch called master, which is the main line of work. In some other version control systems, it's called trunk. Now, the way Git represents branches is using a pointer. So master is pointing to the last commit we have created so far. So as we create new commits, master moves forward to point to the last commit. Now, because we can have multiple branches, Git needs to know what is the branch we're currently working on. To do that, it uses another special pointer called head. So head points to the current branch we're working on, in this case, master. You've seen this before. In our log, you can see head is pointing to master, and this item is in front of the last commit. So as we create new commits, these 2 pointers, head and master, will move forward. Now here's the thing. When we check out a particular commit, the head pointer will move to that commit. This is what we call the detached head. So head is not attached to a branch anymore. It's pointing to a specific commit. In this situation, we should not create new commits. We should only view our code. Here's the reason. If we create a new commit, that commit will be added over here. Now, at some point, we have to attach the head pointer to a branch. Now, there is a problem here. This commit that we just created is not reachable by any other commits or pointers. So it's like a dead commit. Git checks for commits like this periodically and removes them to save space. So we're going to lose that commit and all the changes included in it. So when we are in the detached head state, we should not create new commits. We should only look around and make experimental changes. That is why most of the time, the terminal window changes here Now in my terminal window, you can see we no longer have master here. We have master tilde 9, which means we're 9 steps before the last commit. Now, if we run git log one line, we don't see all the commits we had earlier. Those commits are kind of invisible. And over here on the top, we only have the head pointer. We don't see the master branch. To see all those extra commits, we have to use an additional option called all. Now look, master pointer is in front of the last commit, but the head pointer is here. It's not pointing to master anymore. Now, to attach the head pointer to the master branch, we type git checkout master. Now, as you can see, we're on the master branch and we can create new commits. In this lesson, we're going to talk about an incredibly powerful tool for finding bugs quickly. It's called Bisect. So let's say we have created all these commits, and at this point in time, which is the last commit over here, we have a bug in our application. We don't know where this bug was introduced. Now, we don't want to check out each of these individual commits. That's going to take a long time. So using the bisect command, we can quickly find the commit that introduced the issue. We just have to tell Git that the current state, the current commit is a bad commit, and we should also give it a good state, a good commit. For this demo, let's say this first commit that I created was a good commit. At this point, we did not have the issue. So to find a bad commit, we run git bisect start. Now, we're in the middle of the bisect operation. What you see in your terminal window might look slightly different from what we have here, because I'm on Mac and I have ZSH with git plugin installed. Now, that aside, we should tell Git that the current commit, which is the last commit, is a bad commit. So we type git bisect bad. We should also give it a good commit. So let's bring up the log one more time. I'm going to copy the ID of the first commit and then run git bisect good. And here's the commit ID. Now Git says we have 5 revisions or 5 commits to test, and this roughly requires 3 steps. Look where we are now. We are not on master anymore. We are on bisect / bad tilde 6. So let's run the log command one more time. What's going on here? The head is detached because it's not pointing to master anymore. So let's bring up all the commits using the all option. So master is on the top, and here we have refs or references / bisect / bad. That means this is a bad commit. Now here we have another reference, refs / bisect / good. So here's a good commit. Now head is in the middle point. So Git checked out this commit. Now our working directory is restored to this point in time. So we can run our application or use our automated tests to see if the issue is still there or not. If the issue is there, that means the bug was introduced somewhere around here in the first half of the history. In that case, there is no need to examine the second half. On the other hand, if this is a good commit, the issue was introduced in this half. So once again, we don't need to examine the first half. So we tell Git that this is a good commit, git bisect good. Now we have 2 revisions or 2 commits to test, and this roughly requires 2 steps. So let's look at the log one more time. So we have a bad commit on the top and a good commit over here. The head is in the middle point. So once again, we run our application or use our automated test to see if the issue is still there or not. For this demo, let's say this is a good commit, so we don't have the issue at this point. That means the bug was introduced somewhere here in one of these 2 commits. So we say git bisect good. We have 0 revisions to test and one more step is needed. So let's look at the log one more time. So the head is over here. Now let's say this is a bad commit. So we run git bisect bad. Now let's look at the history one more time. So we have a bad commit, a good commit, and the head is right here. So we run our application and the issue is there. So we tell Git that this is a bad commit. And now Git knows the first bad commit. We have full information about this commit, so we can see the commit ID, the author, the date and time it was created, the message, as well as a summary of the changes. So we can see the list of files that were changed. In this case, we had 2 changes, which involved 2 insertions. So using the bisect tool, we can divide our history in half and check out various commits to find the first bad commit. When we are done, we have to attach the head pointer to the master branch. So we say git bisect reset. Now we're on master. Sometimes we need to find all the people who have contributed to our project. We have a special command for that, git short log. So here you can see my name, the number of commits I have created, and a summary of commit messages. Then here we have various interesting options. So let's run git short log -h. For example, we can use -n or -- numbered, whatever you prefer, to sort the output based on the number of commits per author. We can use -s to suppress commit descriptions and -e to show email addresses. For example, we can say git short log -n. Now the list is sorted based on the number of commits per author. In this repository, we have a single author, so the output doesn't really change, but we can add -s to suppress the commit messages. Now we can only see the number of commits per author. Now in addition to this, we can pass -e to see email addresses of each author. So with this, we can easily find the most active contributors. Here we can also filter the list. For example, we can use before and or after options that we talked about earlier to view the contributors for a given date range. Let's see how we can view the history of a file. For example, we have this file here, table of content.txt. Let's find all the commits that have touched this file. So we run git log table of content.txt. If this is too verbose, we can use the one-line option. That's better. Now we can find statistics about each commit in terms of the number of changes using the stat option. We have seen this before. Now we know in this commit, we have 1 insertion and 1 deletion. In this other commit, we have more changes. So then we can view that particular commit in detail. Now, if we want to see the actual changes in each commit, we can use the patch option. So instead of stat, we use patch. Now we know in this commit, which is our last commit, this line was removed and replaced by a blank line. In the other commit, before that, we added these few lines and so on. So to view the history of a file, we still use the log command, but we append the file name at the end. We all make mistakes. Sometimes we may accidentally delete a file. So let me show you how to recover a deleted file from the history. For this demo, I'm going to remove the table of content file. So we're going to use the rm command to remove toc.txt. Now we have a change. Let's commit it and say remove table of content.txt. Now this message is purely for this demo. In a real situation, the message is not going to indicate that we're deleting a file because that would happen accidentally. So we may remove this file as part of fixing a bug or implementing a new feature, okay? So our table of content file is gone. Now we need to find all the commits that have touched this file. So we run git log, one line, toc.txt. Now here we get this fatal error saying ambiguous argument table of content.txt. This is one of those situations where I told you Git is not able to properly interpret your file name, so you have to separate it from the options using double hyphens. So we bring up the last command and add double hyphens here. So here are all the commits that have touched this file. Obviously, the last commit is the one that has deleted this file because we don't have any further changes to that file after that commit. So now to restore this file, we have to look at the parent of this commit, which is this commit over here. This is where we had the latest version of this file. Because in this commit over here, our table of content file was deleted. So it doesn't exist in this snapshot. So we look at this parent, we take its ID. Now we're going to check out only the table of content file from this commit. So git checkout, commit, and then we add the path to our file. So our working directory is dirty. Let's run a short status. We have one new file that is also in the staging area. So let's commit it and say restore table of content.txt. This is how we can restore a deleted file. Another useful tool in Git is the blame tool. With this, we can find the author of a particular line. So as part of troubleshooting issues, we may wonder who has written that terrible, smelly, disgusting line of code. That's where we use the blame tool to basically blame them for writing that piece of code. Here's an example. Git blame audience.txt. Now, in front of each line of code in this file, we have some extra pieces of information. We can see the commit where this line was inserted. We can see the author's name and the date and time this line was inserted. Now, if we want to find the author's email, we use the -e option, -e. Now, instead of the name, we have the email. We can also filter by lines. So if you have a large file, we don't want to see all these details. Let's say we're only interested in the first 3 lines. So we type git blame -L, and here we say 1, 3. Now we only see the first 3 lines. Quite often, we need to bookmark certain points in the history of our project, like the commit that represents a given version. We use tags for this purpose. Let me show you how this works. So let's say this commit over here, the last commit, represents the first version of our software. So we can give it a tag or a custom label. So we type git tag version 1.0. Now, if you want to tag an earlier commit, we have to type the commit ID or the commit hash here, like 5E, 7A, 828. Now, let's look at our log again. So look, in front of this commit, we have a tag, a label. We can reference this commit using the tag. So if you want to check out this commit, we can say git checkout version 1.0. Exactly the same way we check out a commit using its ID. But instead of the ID, we use this tag or this custom label. Now, to see all the tags we have created, we type git tag. Currently, we have a single tag. This tag that we have created is what we call a lightweight tag. It's just a reference or a pointer to a particular commit. But in Git, we have another type of tag called annotated tag, which is a complete object with a bunch of properties like tagger name, email, and message. So if you want to create an annotated tag, we type git tag -a for annotated. Then we type the tag name, like version 1.1. Now here we need to supply a message, just like creating a commit. So we can say my version 1.1. Of course, this message is redundant. There's no point having this message. But the idea is that with annotated tags, we can associate a message with a tag. Now, let's look at the list of tags. So git tag. Currently, we have 2 tags. We don't see their messages. To see the message, we type git tag -n. So here's our first tag, which is a lightweight tag. The message associated with this tag is actually the message of the commit that it points to. In contrast, here's our annotated tag, which has a custom message. Now let's look at the second tag we just created, git show version 1.1. So on the top, we have some information about this tag. We can see the tagger's name and email, the date and time the tag was created, as well as the custom message we provided. Below that, we have the full details of the commit. So quite often, we prefer annotated tags to lightweight tags. Now, to delete a tag, we type git tag -d and then type the tag name. The tag is gone, so we have only a single tag in our repository. Let's see how we can use VS Code to view the history of our project. To do that, you have to install an extension called GitLens. So go to the extensions panel and search for GitLens. It's right here. This is a very popular extension. Look at the number of downloads. It's over 6 million times. So once you install this, you're going to see a new icon over here. That is GitLens. Now on the top, let's go to repositories. Here's our Venice repository, and we're currently on the master branch. Let's open the master branch. Here are the commits in this branch. For each commit, we can see the message, we can see the author, we can see the number of files that were added, modified, and deleted. Now, if we expand any of these commits, we can see all the files that were changed in that commit. If we click on any of these files, we can see a diff of the changes. So this line was removed and these 2 lines were added. Pretty helpful. Now, let me close the master branch. So over here, we can see all the branches we have. We'll look at branches in the next section. We can see the contributors. So here are all the people who have contributed to this repository. In this case, I'm listed twice because I've created some of these commits on another machine with a different email. So that is why I'm listed twice here. Now, we also have our tags. Currently, we have a single tag, version 1.0, that is referencing this commit. Now, let's look at some file history. So this file history panel works when we have a file open in the editor. So I'm going to open our table of content file. Now, back to GitLens. In the file history panel, we can see all the commits that have touched this file. Once again, if we click on any of these commits, we can see the lines that were added or deleted. Now let's see how we can compare commits. So we click on this. We have to select two commits here. We can type a commit ID or a relative reference using head. I'm going to compare head with head ~6. So these are all the files that have been changed across these two commits. If we click on any of these files, we can see the exact lines that were added or deleted. Now, let's look at search commits. So we can search by message, author, commit ID, files, or changes. So let's search by message. So after message, we type our keyword, let's say GUI. This is the only commit that has the word GUI in its message. Now, earlier in the course, I told you that all these GUI tools have some limitations. For example, here we cannot apply a second filter. We can only search by a single filter like message, author, and so on. If I have so many commits with a particular keyword in their message, and then I want to filter the range to a particular date range, I cannot do that here. I have to go back to the terminal. Another limitation we have here is the lack of bisect command. So we cannot use bisect to quickly find a bad commit. For that, again, we have to go back to the terminal. That is the reason why I'm personally not a fan of GUI tools. I prefer to do things mostly on the terminal. GUI tools are great for diffing, seeing exactly how the code is modified from one commit to another. Now, one last thing before we finish this lesson. Let me show you how to create and delete tags. So we have to bring up the command palette. On Mac, the shortcut is Shift, Command, and P. And on Windows, it's probably Shift, Control, and P. If this doesn't work on your machine, go to the View menu on the top and find the command palette. It's the first item. Unfortunately, it's not visible in my recording window right now. So let's bring up the command palette and type git tag. Now we can see all the commands related to tags. So we can create, delete, or push tags. We'll talk about pushing tags in the future. So let's create a tag. We give it a name, let's say version 1.2. We type a message. And now we have a new tag associated with the latest commit. So if you go to repositories and tags, here's our tag. Now, if you want to create a tag for an earlier commit, you have to find that commit first. So let's say we want to add a tag to this commit right here. We right click and select create tag. Let's see how we can browse the history using Gitkraken. So first we go to open a repository. We go to our project directory and open our repository. So here's the history of our project. We can clearly see all the commits we have created so far. On the left side, we can see our pointers. So master branch is just a pointer to the last commit over here. Now next to master, we have +1, which means we have another pointer pointing to the same commit. Take a look. That is our tag version 1.2. We have another tag pointing to this commit. Now we can search for commits right here. Here we can find commits by their ID, author, or message. So if I type GUI, this is the only commit that has the word GUI in its message. Now, as I told you before, all these GUI tools have some limitations. For example, here we cannot find commits created by a given author in a particular date range. So we cannot apply multiple filters. In those situations, we just have to go back to the terminal. Now we can select any of these commits to see its details. So here on the right side, we can see the commit ID, message, author, as well as a summary of modified files. So here we have modified 5 files. We can see all these files listed here. We can sort the list in ascending or descending order. We can see the list in the tree structure or in a flat list. Now we have a very useful option here, view all files. So if this commit has modified only 2 files, but we want to look at the other files in our project at that point in time, we can select this and open any of these files. For example, here, salespage.txt hasn't been modified. That's why we don't have an icon next to it. But we can click on it to see what it looked like at that point in time. Now let's look at our table of content file. So here's the final version of this file stored in this commit. To see the actual changes, we go to the diff view tab. So you can see this line was removed and replaced by blank line. I totally love the diff view in Gitkraken. It makes our job a lot easier. We also have two tabs here, blame and history, which kind of bring us to the same view. Let me show you. So we can go to history. Here on the left, you can see all the commits that have touched this file. Here's the first commit, and here's the last commit. So as we look at this commit, we can see how this file has evolved. So let's change the diff view to file view. In the first commit, our file was empty. In the second commit, we added these lines. And in the last commit, we removed the border under the header. Now, if you click on the blame tab here, unfortunately, it's not visible in my recording window. But if we click on it, we can toggle blame details. So this line was added in this commit over here by this person. So we can clearly see who has written what line of code. Now let's close this window and this window as well. Back to our history. Let's see how we can compare two commits. So I'm going to compare this commit with this commit over here. To select the second commit, we press Command on Mac or Control on Windows. Now on the right side, you can see we have selected two commits. And here are the files that have been changed across these two commits. So this is how we can compare commits. Now, if we right-click on any of these commits, we can check out that commit. All right, now look, the head pointer is pointing to this commit. So it's in the detached state. Now to attach it back to the master branch, we right-click the master branch and go to Checkout Master. Good. Now, one more thing here. We can right-click a commit and create a tag or an annotated tag. We have a bunch of other commands here. We'll talk about them in the future. So this is how we can browse the history in Gitkraken. Now, before we finish this lesson, let me show you another useful feature here. We can bring up the command palette by pressing Command and P on Mac or Control and P on Windows. Here we have various commands. We can select the blame command, and then here we can search for a file in our project. Let's say table of content.txt. So we have auto-completion. This is fantastic. I love it. So let's look at table of content. Now we can see the full history of this file. We can see we accidentally deleted this file in this commit and then added it back over here. And of course, if we toggle the blame details, we can see who has written what line of code. Very handy. Now let's bring up the command palette one more time. We can also search for commits. So we can search by message, like GUI, or by author, or by commit ID, and so on. Using the command palette, we can also create tags. So let's search for tag. Now we can create a tag. This will create the tag for the last commit in our repository. To create a tag for an earlier commit, as I told you, we have to right-click that commit and go to Create Tag. In this section, we're going to talk about one of the most important and powerful features of Git called branching. You will learn how to use branches to diverge from the main line of development and work on something else in isolation, how to compare branches to see their differences, how to merge them. We'll talk about different merging techniques like three-way merging, fast forwarding, squash merging, and rebasing. We'll also talk about resolving merge conflicts, undoing a faulty merge, and using essential tools like stashing and cherry picking. The skills you're going to learn in this section can totally change the way you develop software. So let's jump in and get started. So what is branching all about? Well, branching allows us to diverge from the main line of work and work on something else in isolation. Conceptually, you can think of a branch like a separate, isolated workspace. So we have our main workspace, which is called master. We can have another workspace for working on a new feature in isolation. While we're developing this new feature, our code may get unstable. So we don't want to release the code in this workspace. We continue working here. When we're done, we test our code, and after we fix all the bugs, then we bring the changes in this workspace into the master. This is called merging. So branching allows us to work on different work items without messing up with the main line of work. We keep the main line as stable as possible so we can release it anytime. Also, anyone joining our team can start off on a stable code base. That's the idea of branching. Now, the way Git manages branches is very different from many other version control systems like Subversion. In Subversion, when we create a new branch, Subversion takes a copy of our entire working directory and stores it somewhere else. What if we have hundreds or thousands of files in our project? All these files have to be copied, and this operation can take a little while. That's why a lot of Subversion users hate branching, because it's slow